Sören Krause, and we're going to step now a little bit back from the real data to synthetic data. And we will start now first with the motivation, because what we're going to do the synthetic point cloud generation. The paper is titled synthetic 3D point clouds generated through LLM discussion, and how it works we're gonna figure out later. So let's go to the motivation a little bit. And what is the bottleneck we're going to aim? The bottleneck we're going to aim is we need large scale data sets. And that large scale data sets are not available for point cloud reconstruction, for the segmentation, for the classification, or something else. Because every scene or every diverse scene of the point cloud sector needs a diverse data set to test things on. And what's the next problem? Where does the training data come from? The training data is coming from the manual segmentation of point clouds, the annotation of that point clouds. And this point is really time consuming. So we want to overcome this gap a little bit with the approach, and we're gonna figure out a new framework for the data generation to the synthetic data part. It's really easy. So the framework works we're going to make a prompt. The prompt is generating code, and the code is generating at the end the point cloud. So the point cloud is then directly annotated, and we can use it for the classification or the segmentation and so on. How was the research question? The research question is we have not a new framework or something like that. So there are a lot of iterative frameworks for other directions and something like that. But we have the new framework for the point cloud synthetic data generation and so on. So, and at this point we take two research questions regarding the framework. So the first research question is how reliable does the proposed SYN3D-LLM framework generate executable point cloud code under the iterative designer-critic refinements? And on the other side, we have the accuracy of the generated data. So we need to check, is the data aligned to our prompt and is it working? Because we do not want to have a lot of hallucinations and something like that. And the framework works like that. So we have first the user instruction. The user instruction can be this little sentence, okay, generate a bridge or something like that. Then we have a stable designer prompt. That's the next slide. And the stable designer prompt is written how to construct the point cloud with the LLM. So that the LLM is guided for okay, you're going to make a code in Python code, and the code looks like that. So the code is at the end executable. That's the biggest thing. And the next thing is how we're going to get it better, because we haven't an understanding of unstructured point cloud data by large language models because of the behavior of the data. And that's where we're gonna use the code. And there's the discussion. So we have after the first prompts, a critiker. The critiker is having a stable prompt for critic about the point cloud and the code and something like that. Then we have another designer, and it gets end discussions to the end iterations to the workflow. Afterwards, we're going to check is the code executable, because if we are not getting executable code, it's useless. We don't have a point cloud. For that, we're gonna take 3 tries into the system first, but you can make it higher or lower. That's what you want at the end. And if you've got an invalid point cloud, we got the next point. So we're going to deliver helper functions to the large language model to build the point cloud. So we're gonna go in the next slide to help functions. So the validation of the system was over 300 runs. We got a validation matrix for that one. So we have on the left side the scene diversity we generated about it. It was an apartment, bridges, high-rise buildings, industrial buildings, intersections of roads. Then we have railway tracks and some single-family houses and something like that. You can do a lot of more things like that with the approach. And then we have the helper functions. The helper functions are really quite easy. So the first helper function is we're gonna deliver nothing to the LLM, so no guide. Then we have the minimal prompt with how to create plane surfaces as code and Python code for the point cloud. Then we have like the rectangle boxes with round objects. And at the end we have like rectangle boxes, round objects, and specialized objects. Specialized objects are like occlusions in the point cloud. So you have some noise in the point cloud and something like that. So, and the prompt variations at the downstream of the metrics is like the baseline prompt. So we're gonna change the baseline prompt to like, okay, make it more clear or make it with more occlusions in the prompt at the end. So we have like the diversity of the data a little bit for the data sets, etc. What is the result of that? The result is at the end point. So the executable code is like in different diverse themes. We have apartments, we have courtyards, family houses, then we have like road signs, rail tracks, intersections, industrial halls, and high-rise buildings. And that's like the point of the proposed framework. So we have for every diverse scene in the construction site different labeled point clouds that we can use for like the classification and segmentation. What was the influence of the iterations? We can see it here. It's like, first we have like a little building, it's an apartment. So we have like 3 windows in the apartment. Iterations is going like to make the ceilings, align a little bit the windows and other objects in the iteration. Same for the bridge. The bridge deck is like built from it at the end. And we have like, it's like we're going to slice it. It looks like a real bridge at the end. There are some missing objects, so it's not perfect. But it's like the first step in the first direction. So what was the results mean? The executable code works best for like the helper function G2 box surfaces. So the model is able to generate boxes. And that was like the best way to work with it. But all configurations of like the helper functions delivered after like 6 tries executable code. So it is a little bit cost intensive, but it works. And then we have the semantic check. The semantic check and geometric check works out from the prompt. We have the scene prompt, there's information for the geometric, and then we have like the required IC elements we want to have from the IC model at the end, and we can check it with like the delivered point cloud from the code. What is the conclusion at the end? So the conclusion is the framework generates executable code. Yes, it doesn't. And the helper functions, especially the G2 helper function with like the box surfaces, improved the first iteration should step a lot. So, and then we have for the research question 2, we have like the plausibility and consistency of the point cloud, which is measured by the dimensions we got into the prompt. And these dimensions are really good for like the houses and the little objects, but for bigger objects like the intersections, railway tracks and something like that, that were quite bad. So there's a big gap between the dimensions of the measured point. What are the limitations? So we have the synthetic to real gap. That's like a normal thing first, because the occlusions are not so good implemented at the end of the point cloud. Then we have strong dependencies on the prompts, and we have limited Scan-to-BIM validation at the end. That needs to be like the next step of the research. And the outlook is like, okay, defining some stopping criteria, because the cost of the API were like quite high. And we need to reduce a little bit the API costs, and we need to integrate explicit sensor models, improve the geometric control, and use the generated data for the Scan-to-BIM approaches. Yeah, thanks for listening, and if you're interested in